Work at the Carnegie Foundation. I am accompanied today with Hiro Yamada. Hiro is the Director of Analytics, and together we will be presenting on real-time indicator and targeted support using online platform data to accelerate student learning. I must confess that the title is a little bit optimistic. It's near real data, real-time, and some of it is real-time, and it's a little bit aspirational at this point. So this is the general agenda. So I'll give you a little bit of background on the Carnegie Foundation and the problem we're trying to solve, and then we'll go into more details about the analysis and the results. So we're located in Stanford, California, right there. And since 1906, the Carnegie Foundation has been developing products. If you know the Carnegie classifications, the TIA-CREF, the Carnegie units, et cetera, et cetera. We're known as an institution that develops products. More recently, through the presentation of Tony Brake in the last 8 years, we've been concentrating on the field of improvement science and the networked improvement communities. One of the things that we strive to do and what we realize is the education field in the United States and elsewhere is advancing, but not at the same pace of our aspirations. We can't keep continuing doing the same things, relying on policy and top-down implementations, but more so relying on improvement networks and collecting the wisdom of the crowd in addition to the rigorous methods of improvement science and continuous improvement. So this is the problem we're trying to solve. Every year in the United States, there are 60% of students that come to community colleges require remedial math. Out of these 60%, 80% only acquire college credit, which leave us every year with 500,000 students that fail acquiring college math. So in community college, math becomes a gatekeeper and not a gateway for students. So we decided to work on this problem because of its high leverage and using the methods of improvement science and network improvement community, we collectively with the network of practitioners and researchers came up with a solution, and this is the solution that we came up with. The solution is called StatWay. So this is what happened in traditional math sequence. You would take in the first semester your elementary algebra, second semester you take the intermediate algebra, and third semester or more to gain college math. And that is what happens currently, and that's what you get with the 500,000 students a year not attaining the college math credit. StatWay, it's a pathway, and tries to help students get college math credit in 1 year. Sometimes I'll be referring to StatWay as StatWay 1 and StatWay 2. It's a one pathway, but it's split usually in 2 semesters. Some of our colleges are teaching the StatWay in 1 semester. This is the anatomy of the Carnegie Math Pathway Network. So basically, the idea is we collectively, us serving as a hub, many practitioners and researchers work together on solving this problem. And the solution that we're going to present is a solution that came out of this network. This network currently has about 48 institutions around the United States, 96 administrators and leaders. Those are your deans, your math chairs, your student services, et cetera. There are 14 faculty mentors in this network, 40 faculty facilitators, 318 faculties and TAs, maybe more TAs, and about 8,000 students. This is the theory of improvement. This is our driver diagram. So basically our goal, the goal of this network, is to increase the number of students achieving college math credit within 1 year of continuous improvement. How do we accomplish this? Is through these drivers. The first driver, as I mentioned, is an accelerated pathway through college level math. The second driver is we have to have a quality system of instructions. Third is the productive persistence. This is, if you're familiar with the work of Carol Dweck with growth mindset, not only we work on the cognitive aspects of learning, we work on the non-cognitive aspects of learning and the social-emotional and how students get a sense of belonging in the classroom and develop learning strategy. The fourth is the language support. We believe that if we lower the barrier of the language itself and the literacy, we can allow students to understand and grasp math concepts without having to deal with complex language. To teach this, we need a support for the faculty, because this is not your traditional instruction system. This is something different that needs faculty to be mentored and at the same time trained on this pedagogy. And last, as I mentioned, this is a networked improvement community, and for short we call them NICs. So the NIC operates itself. The Carnegie Foundation serves as a hub of expertise for analytics, collaborative technology, improvement science, and network development. So this is the theory of practice, and these are the different drivers. I'll dig into a little bit of some of the drivers, but not all of them. This is the instructional system. So the instructional system is mainly based on learning opportunities, and that contain productive struggle. Strategically, the quizzes and the problems in the curriculum have struggle implemented, so students have to grapple with the issue, and then some scaffolding gets implemented. Students must make, through this curriculum, explicit connections, and there is a deliberate amount of practice. We don't call them quizzes, we call them, did I get this? We use specific language that supports the productive persistence, the non-cognitive aspect of learning. We call them, did I get this? Learning by doing, out of class experience. We use that language. There's another pathway, it's called Quantway, but we're not going to mention this in this presentation. Quantway is quantitative reasoning and serves different purpose, but it's similar implementation as Statway, which is a statistic course. So the pedagogy is research-based, collaborative. Students are working in groups. Faculty usually works as a facilitator rather than a lecturer. And the language and literacy support and the productive persistence is woven into the curriculum. This is not something you're going to do on the side. We're going to work on your mindset. You're working on your mindset and your growth mindset as you're actually learning and you're going through the curriculum. We have what we call a starting strong package, which is an implementation of growth mindset exercises and interventions that are woven through the curriculum. This is the map of where the pathway is. We are expanding currently in the state of California and New York. There's about 48 colleges, and this is rapidly expanding. We actually implemented some of the pathway in dual credit high school institutions in the United States, but they're not represented in this graph. These are the results. What success rate was happening in 2 years, now in 1 year, we moved from 16% to 55% success rate. So that's literally tripling the success in half of the time. This is the distribution on subgroups, and where you can see that we have the highest impact to push the equity agenda with Hispanic, African Americans, and females. This is a comparative analysis. Let's say, Hiro can talk more about that later. It's a propensity score matching between equivalent matched students, between the light blue and the dark blue. Those are matched students. The team that I lead is called the Collaborative Technology Team. And in case you're interested, the gray folks on the right side there, we're hiring. We're hiring the full stack engineer and project manager. So if you're interested, So we have a small team of 6 people, engineers, database managers, and designers. And this is the Carnegie Foundation. I showed you the aerial view. This is actually close-up view. And the collaborative technology team lives here. Some people call it the basement. We call it the garden level. And this is our collaborative technology, our driver diagram. This is what we do. We try to support this NIC, which is the Community College Pathway Program. We support the technical operation, the data infrastructure of collecting and reporting on data, the online collaboration between these members of this network, and the knowledge management. We also develop our own hub capacity, and we have developed the hub capacity at these institutions. Again, these are 48 institutions outside of the Carnegie Foundation, and we help them do analysis and support technology at times. So this is what emerged out of the solution, is what we call Carnegie Hub. Carnegie Hub is a responsive online platform that we created to support all this work. By the way, the URL is pathways.carnegiehub.org for that one. We're built on a Google infrastructure. They're just down the street from us. And they helped with some of the implementation of some of the apps that we use for the collaboration. This is the core architecture of how this network works in with regards to improvement science and network improvement communities, and also generation of knowledge. At its core is the driver diagram, the DD right there. That's what I mentioned earlier, the big aim, the big hairy aim of giving students the chance to see mathematics as a gateway and not as a gatekeeper. Around that is what we know in improvement science as PDSAs, plan, do, study, and act cycles. In addition to that, there is what we call ideation. There are a lot of folks that want to be part of this network, but they lack the cognitive knowledge of how to do PDSA or why PDSAs are important. So we allow for some ideation, and this is what the group affinity. And then hoping that at some point, they will be doing the improvement with big I, which would be through quality PDSA. Out of this, this platform encourages social learning. Faculty to faculty, administrators to administrators, all on this platform can collaborate, can share knowledge and share insights and findings. And what we end up doing is create curated knowledge, or what we call change packages. What works across different environments, different contexts, and this is some sort of information that we share with everyone. And of course, we see this as a scientific community, so that's hence the curation, the common vernacular, and common taxonomy, and folksonomy in some sense. This is what a PDSA cycle looks like. So basically, you have a hunch, a faculty or someone in the NIC has a hunch. They test the idea, they plan it, they do it, they study it, and they act upon it. And they start with something small and work their way up in a ramp. And if it's successful and can transcend local context, there is something to be seen there, something to be shared, some learning to be done there. So who's in this Carnegie Hub network? So students, faculty, TAs, admins, explorers, and staff, they all go to the Carnegie Hub. It's a portal-based system, so it will morph as depending on the role, and that's will display relevant information for these different roles. I have to go very fast. So basically, it is a platform. There's a portal in the front. There's an LMS and a math assessment engine in the back end. It allows for some of the collaboration, as I mentioned. It also some of the management of the enrollment, and these are institutions foreign to the Carnegie Foundation, so we have to help them manage their enrollments. It's all happened through this platform. The type of data that we collect is student production data that happens as they are on the platform, Clickstream data. The productive persistence, we measure that, how students feel about their classroom, how they feel with their peers and their teacher. and the institutional data about the specific institution, and some information about the faculty and who's mentoring who, etc. So within a term, let's say this is a term, it started at a certain date and ends at a certain date. There's multiple courses, pathway, statway courses. At the beginning, what we do, we survey the student. We call this productive persistent time 1. And as soon as it opens for 9 days, and then we provide a report to the faculty. And then we have the math conceptual knowledge, basically testing the knowledge of the students in cognitive knowledge of math. And then we provide a report. We do that, we do the implementation, and then we do it again in week 4. We measure again, we report to the faculty, and we do it 3 times during that term. So these are an example of the reports. This is the math conceptual knowledge at its high, medium, low for different students. This is the engagement data that they see, faculty sees. And this is the productive persistence time 1. So this is what basically see the time 1, time 2, or time 3. This is how actually the thing got moved from one time to another. And this is how students are moving across different time sets. So this is like an institutional report that we provide once a year. And I'm going to cut this short because I'm going to move this to my colleague here to talk more about the analytics behind.
Okay, so we have a limited time, so I'm going to skip this part. But basically, the point is earlier, George showed 16% and 55%. So we made a success. But if you start looking at this, this is a failure pattern. So this indicates that majority failed in statway 1, which means first course of the sequence. So that's why we want to focus on first month in the first course of the study to create some sort of practical system of indicators to flag students. Then we have 3 different data sources: productive persistence, non-cognitive aspects of factors, and cognitive aspect, math concepts, then engagement with online platform. So method is, so analytic sample, this is the sample size we got from 58 classrooms and 21 colleges. Data is through 2 years ago. Then, as he mentioned, roughly the first week of the class, we collected 2 data sources. Then we're gonna track data over a month. So I'm gonna quickly go. So this is a kind of set of indicators, 2 parts: self-perceptions and also perceptions of the classroom settings. So fixed mindset, stereotype threat. These are 2 famous psychological constructs, Carol Dweck and Claudy Steele. And belonging uncertainty, whether I belong to class or not, that's also influence academic achievement. They also comfort asking questions in class. Professor cares how much this particular instructor cares about me or student success. Then basically for 5 indicators, we dichotomize at risk, not at risk, based on prior analysis. Then this is MCK, 21 items. This is a kind of quick assessment at entry point to statway 1 course to know what level they are in. So single score create 3 levels: high, medium, low. I can talk more offline if you are interested in. Then this is a quick stream data. We focus on quiz submission. So practice quiz, earlier Jojo mentioned learn by doing, and did I get this? Not graded, but also each at the end of the module and end of the topic, we have some sort of summative assessment, like 20 items. Then we focused on at least 1 attempt, whether they at least submitted quiz. Then formulated level of engagement by looking at the data distribution. 6 levels for practice quiz and 4 levels for checkpoints. And outcome is grade, success C or higher, and the rest is non-success. So we use latent class analysis to the time 1 data, productive persistence and MCK, time 2 data, after a month, online engagement. Then compute success rate. Well, I'm going to skip this because here's the data. So this is based on time one data. So each column represents segment, and 24% of students fall into that first one. Then success rate is 87%. So as you can see, lower risk, higher MCK level, definitely the highest success rate. The non-engagement means they didn't do anything. Basically, they didn't complete survey or MCK. So I didn't want to throw away as missing data because this has some meaning to it. Then this is just focusing on online engagement part. Again, another 4 segments. 4 means 100% of engagement, submission for practice quiz, and checkpoint. Then some, again, no engagement. So success rate along with it. Majority fall into some and full engagement. So this is a time one engagement. Now I'm going to show how success rate change over time based on the first and second time segments. So this is the first segment, starting 87%. Then mostly, maintaining a high success rate. Then I color coded for these first 3 segments. I applied 80% rule. 80% of the students fall into that. Then I color coded. Green means high, and you see later red. That's the lowest success rate. No engagement is basically small sample size. That's why I didn't highlight it. Then this is medium risk. This is this. So basically, the point is, let's say third segment, higher risk productive persistence, middle MCK, but if they attempt interacting with online engagement, success rate goes up. That's one key takeaway. And also non-engagement, if they engage a little bit more, then definitely likelihood increase. So this is the next step. So validate our findings against the most recent data, because more data points and easier data retrieval. And also, Jojo's team developed a great portal for quality data collection. And also utilize data beyond the first month. That's more challenging part for us, because earlier Blackboard team indicated that we noticed that there are variation between colleges and also between classrooms in terms of engagement patterns. But also we try to measure classroom or college climate or culture to predict student success by using existing data. So basically, we have nested structure of data student in classroom, nested within college. Accordingly, we're going to use hierarchical linear modeling approach to analyze data to try to tease out what effects, like student level effects, classroom effects, or even college effects, how they influence student success. I'm sorry, quickly I went through, but that's it.